This problem tests how well you know the Pythagorean theorem. Line segment OA forms a right triangle with angle OCA. The right triangle has a hypotenuse of line segment OA with sides of line segments OC and line segment AC. If you look at the right triangle shown, the length of its hypotenuse h is related to the lengths of its sides S1 and S2 through the Pythagorean theorem. H squared is equal to S1 squared plus S2 squared. So for triangle OAC, the length of line segment OA squared is equal to the length of line segment OC squared plus the length of line segment AC squared. Since the length of line segment AC is equal to the length of line segments AB plus the length of line segment BC, it's equal to 5. 1 plus 4 is 5. So the length of line segment OA squared is equal to the length of line segment OC squared plus 5 squared. Since line segment OB forms right triangle OBC, we can use the Pythagorean theorem again. Triangle OBC has line segment OB for its hypotenuse. So the length of OB squared is equal to the length of line segment OC squared plus the length of line segment BC squared, which is 4 squared. Likewise, the length of line segment OD forms the right triangle OCD, and the hypotenuse again is line segment OD. The length of line segment OD squared is equal to the length of line segment OC squared plus the length of line segment CD squared, which is 3 squared. Finally, we see that line segment OE forms triangle OCE. Line segment OE is the hypotenuse of triangle OCE. Therefore, the length of line segment OE squared is equal to the length of line segment OC squared plus the length of line segment CE squared. Since the length of line segment CE consists of the lengths of line segments CD plus line segment DE, it's equal to 3 plus 3, and so the length of line segment CE is 6. Therefore, the length of line segment OE squared is equal to the length of line segment OC squared plus 6 squared. Each of these line segments, OA, OB, OD, and OE, must be longer than the length of line segment OC because they're equal to the sum, their square is equal to the sum of OC squared plus some other number. So they all must be longer. The length of line segment OE is longest because it is equal to the length, because its square is equal to the length of line segment OC squared plus some other number, and the number that's added to it is largest for line segment OE. Therefore, line segment OE is the longest.